So let's start with mobile basics. What's in that? First of all, we will see a little bit about networks. I will show you how mobile networks work, a little bit about the history, how they grew in the last years, how it came up to that what we have today with 4G or 5G data reception anywhere and every time we want. But I will start with history and also explain you some real basics and knowledge about networks. First of all, about history. That's nothing that you have to learn, and that's nothing that comes up at a test or anywhere else. That's just a collection for you from several years where the evolution of mobile networks took place. And I just want to point out those years where, for example, a country like Austria was also involved, because Austria always had a special role in the whole world of mobile communication. We were always in the middle or in front of the evolution of networks, especially in Europe. In 1972, we had something called like BNet. That was the first analog cell phone network, and it was only available for 27,000 people in the whole country of Austria. So that was the history. The reason why only 27,000 users were able to have a phone call was based on a few perspectives. One for sure was money. Price for such a mobile phone was very, very high. It was in the area of 10,000 shillings and more, which was quite a lot in the past. And the second reason was it was due to technology. We did not have the situation like today that we had digital data and digital transformation. We had an analog network, which means having a phone call had the same principles and basis like listening to the radio today. I will come back to that reason a little bit later. But the situation all over Europe was not very confident, and that was the reason why in 1982, on a big conference, the European Conference for Post and Telecommunication, which is today the Mobile World Congress. So maybe one of you or the other of you knows every year, normally in the beginning of the year, around February, there is a Mobile World Congress where all the different companies, handset manufacturers, software manufacturers, hardware companies come together, have meetings, talk about the future possibilities, etc., etc. That was also in 1982. And in 1982, the situation was quite different than today, because we had no chance that everybody in each country could have phone calls. We had no chance to go with our phone over the border and have a phone call with an Austrian phone in, for example, Germany or anywhere else. And for that reason, some companies formed a work group and decided to form a work group. There were companies from 26 different European countries who came together and said, we need solutions for having a mobile network that works all over Europe. So they were Europeans and they were thinking about Europe first. And then they started. Then it was quite quick, as it always is in telecommunication or technology business. It did not last very long until the next networks were launched. 2 years later, the CNET came up. Then 6 years later, the DNET came up. These were all different networks with different new technologies behind, but nevertheless, they were analog and they always had the same bottleneck. They need to have one frequency for one phone call, and frequencies were limited in the air. So not everybody could have phone calls. Besides the quality of analog networks, which was worse, there were a lot of troubles. At the end of the day, 12 years after that work group was formed in the year 1994, we had the first GSM network, the first digital network. It was also called first generation network, 1G. And that was launched all over Europe as well as in Austria. So let me talk about this GSM topic now, and let me switch to the next slide. This group that was formed in the year 1982, this group was called GSM. Anybody of you having an idea for what G, S, and M stands for or stood for in the past? No idea. You can also use the chat function.
I'm guessing geographical system for mobile technology.
Yeah, two things are not far away. The system and the mobile is quite right. The G was something different. The very first step, this group was called
Global
Spécial Mobile. So these were, because why? It was a French name, and it were 4 physicians from France who formed this work group. So that was an internal name. But at the end, when they started their work and they thought about it should be something that we can use globally and not only in Europe, they came up with the name, what it is today. And it's quite close to what you said, Konrad. It's the Global System for Mobile Communication. And this is still the name today. GSM stands for Global System for Mobile Communication. So those guys who came together in 1982, those 4 French physicians, quite soon recognized that it should not be only a European development what they do, it should be something that could be used all over the world, which was still not the case in the beginning, but today it is. And the name did not change. So GSM means Global System for Mobile Communication. And the abbreviations that you get in the daily news sometimes, for example, when you today read about 5G, the G always stands for the generation of GSM. So 1G was the first generation, 2G the second, 3G was UMTS, 4G was LTE, and 5G is now a standard which is developed. So this G stands also for the generation of the Global System for Mobile Communication. That's something about history. So let me come up why this work group was formed and why they had round about 12 years of development of mobile networks and the definition of mobile networks. There were 4 clear reasons. The first reason was, as I told you, in the analog networks, first reason, there was no roaming. People could not take their phone, cross a border, no matter where, if in the USA, in China, Italy, Austria, and having phone calls there. The analog networks only had the chance to have phone calls in your own country because every phone was related to a certain frequency. And the same frequency was maybe used for something different in another country. So first reason was these guys who formed the group Spécial Mobile and who did the research for establishing a global system for mobile communication. Those guys had the first goal to enable people for roaming. Second goal was, also as I told you, the access was limited. For example, in the Austrian BNet, only 27,000 people could attend and having phones and phone calls. Second goal of that work group was for the global system of mobile communication that everybody, in theory, can have phone calls, can have phones, and is able, no matter where he is, to establish phone calls, data traffic, or SMS. So allow access for more users was the second goal. Third goal, quality. Still today, but especially in the past, and especially before the first generation of GSM, in the analog world, quality was a big issue. It was not possible having a phone call during, for example, driving a car without any interruptions. Because of analog frequency topics, there were always breaks in between, and there were always call drops, etc. Still, we have it today. I will give you also some facts why that is the case. But in the old world, before the digital communication networks on mobile, before 1982, that was quite worse. So having a higher quality standard for the mobile radio network was their third goal. And the fourth and last goal was competition, especially among the handset manufacturers. Because in the older networks, in the analog networks, there was no possibility to change your phone. You bought the phone, and in the phone, there was everything completely stuck. So your number, your frequency, everything was there. You could not have a SIM card like we know it today. There was no SIM card. Everything was as a hardware and software solution in one thing in the phone. So losing your phone in an analog network was the worst that you can have, because you lost also your number, you lost everything. And having competition was not possible. You could not have, for example, a mobile phone and say, I will have this mobile phone and I will use this network. The network was always combined with the phone. And the fourth goal of them was having an open market, having competition, and having a separation of phones and networks. That is what we live today, because if anybody wants to change his phone, it's no problem. If anybody wants to change the network, but stay with his old phone, also no problem. So these were the four goals, here also in a list, that the Group Special Mobile had when they started their work. I got one question now from Miriam, and I can say yes, I will also, if you want, upload the recording to Moodle, if that's possible from the data size. Yeah. All right, that were the basics of the Group Special Mobile, and that is also the basics of the GSM network as we have it today. So let's make one step further into technology, and as I told you, my session is the most, let's say, technical oriented ones, because now we make a step into how does it work that we have a phone here in our hands making a call, and that maybe 100 people at the same time at the same place can have phone calls. How does it work? Because I already now told you a little bit about limitations, and I told you about these four goals now, and now let's see in the practical life, in the daily life, how that is handled. First of all, I have to talk about frequencies and about cellular network structure. As I told you, everything that happens during a transformation over the air, a data transformation over the air, no matter if that's a radio signal, no matter if it's a TV signal, no matter if it's a voice signal from a mobile phone or from a walkie-talkie or whatever, everything that we send over the air needs to have a transporter. Let's compare it with, we send a package with the post, and the transporter is a truck running on a highway. And that's what we have as a transporter in the digital world for our voice, for example, in a GSM network, is a frequency. So when we talk, we need to have anything that transforms our voice or our data, if we send emails or watch videos, and sets it on a transporter that it comes to the base station and at the end comes wherever to the receiver if you talk to somebody. So frequency is the first main and big issue in the digital network life. And what's the secret behind those frequencies? The first thing is to keep it short. You cannot use every frequency to transport data or especially voice, because there are limitations, physical limitations, and for example, limitations for having a certain time until the signal reaches the end and so on. So that's the reason why it was one big issue to find a frequency or to find frequencies all over the world and all over Europe in the beginning, which are free in every country. And there was only a corridor from the technology in which frequency you can do voice transmission. Everybody of you knows the radio network systems we have. For example, when you listen to radio in Austria, you have different frequencies like, I don't know, 88.6 or 104.2, depending on the sender station that you use. Radio is a thing where there is one radio station, they send out music on one frequency, and the receivers are only listening. This can happen on a long wave, for example, 88.6 megahertz, and it is only one way. Why it was a little bit more complex in the GSM world is, for example, due to the fact that it's not only one-way communication, it's two-way communication, because somebody talks, somebody listens, and then talks back. So we need two ways. This was, for example, one reason why you need, for example, a higher frequency. And at the end of the day, to keep the story short, round about 900 megahertz. That was the frequency that this group Special Mobile figured out as a suitable frequency range where people can talk. So a main reason for having this roaming topic and for having a coverage all over Europe was, first of all, they had to look in each country if there is a frequency round about 900 megahertz that is free in every country. Otherwise, it would not work that a mobile phone, for example, from Austria, who is listening and working on the frequency 900, moves to another country like Spain or the UK or Switzerland, when there is, for example, I don't know, 600 megahertz. Because this phone is listening on 900, in another country they send on 600, they won't reach each other. So this was a political issue and not only a technical issue. The second thing is that frequencies are limited and you only can have ranges. The owners of the frequencies are everywhere the states and the national authorities for telecommunication. In Austria, for example, it's called in German Rundfunk- und Technologiebehörde. Abbreviation is RTR, so Rundfunk- und Telekommunikationsregulator, a very Austrian word. And they are from the national authority and they handle all the frequencies that are used in the country. But it's the same in Germany, all over Europe, all over the world, in other countries. And the national authorities, they collect a lot of money for making such frequency auctions. So if you're a company who wants to use a frequency, you have to go to the national authority and they make mostly a bidding system, and you can bid for having a frequency, and if you bid enough, you will get it. So frequencies are a topic, and frequencies are limited. GSM in the first generation was using the frequency at the end of the day of 900 megahertz. And round about 900 megahertz, every country all over Europe in the beginning formed their mobile networks. For example, in the past, in the US, they had a different frequency. They had 1900 megahertz. In Europe, we had 900 megahertz. That was the reason why many years, all the people, for example, who flew on holiday to the United States could not have phone calls with their European phone in the US, because their European phone was listening on 900 megahertz, and the US sender stations were sending on 1900 megahertz. So they did not find each other. You could not use your phone in the United States as being a European. Years later, around about the year 2000, they also started to establish 900 megahertz networks in the US. Then it was possible. So these are all small political and economical situations we have. All right. Then let's come to the explanation how it now works when we have a phone call or we send an SMS, and what's the limitations behind. That slide is only for those who want to go deep dive into technology. I won't talk about it, but I want to give you the opportunity if you are interested. It's about bits, and it's about time, and it's about time division, multiplex access, how fast the signal runs, etc. I try to explain that to you in a different way, and I will make some short painting for that. Therefore, I turn off my video and I open my whiteboard for you, that you can see what I'm painting. So every one of you should now see the whiteboard. Please chat if it's not working, but I think it works. Looks good. All right. Let me, even if it's winter and Corona time, let me explain the system, how it works of having phone calls and using frequencies with an explanation of a skiing area. And I think for sure everybody of you knows how to drive with a gondol from down to the top. And that's what I will paint here for you. Let's say that's the top of the mountain. And that's the bottom where we all enter. And here on that circle, we have different gondolas. In our explanation now, we have 8 gondolas. One, two, three, four, 1, 2, 3, 4. So that's the gondola number 1, number 2, etc., etc. 3, 4, 5, 6, 7, and 8. And the rope is our frequency. And our frequency is, for example, 900 megahertz, a GSM network frequency. And now the system works like this at the end of the day. When you live in a house with many people, or when you're sitting in a university or, I don't know, an office building, there are for sure not only one people who want to have a phone call at the same time in a network. If it's, for example, Magenta or Evo1 or 3 Hutchinson in Austria, whatever. So if this is, for example, one network, they have in a building a base station with a frequency of 900 megahertz. And on that frequency, when you now start a phone call, it works like this, that on the frequency of 900 megahertz, your phone, where you have a phone call, gets one gondel for the time of the call. And now the thing is, as you can imagine, for having a skiing area with gondolas, you know that they rotate. They drive in the circle. When you start to talk, every 4.615 milliseconds, your gondel comes where you can talk. And then you have a time of 576 microseconds where you can enter the gondel and can speak. Everything that happens in between is for nothing. But in reality, that happens so fast that when you talk, you don't get it, and especially the ear of the receiver at the top, who is your communication partner, also having a mobile phone. The ear of your receiver, of your partner who is talking to you, also does not get it, that in reality, that what you speak has a break of 4.615 milliseconds. That is something what, for example, the guys, the physicians, found out during their research in 1982, that the signal on one frequency can be divided. And that's one of the most important secrets behind. That's why the thing is called, as you saw it on my slide, time division multiplex access, because in time slots, we have access for talking on one and the same frequency. And that means at the same place, at the same time, on the same frequency, 8 other people or 7 other people can talk. And that was very important for reaching the goal of supplying a mobile network for all users in every country. So when you talk, this is one that you can remember, one fact that you can remember, that what you talk is divided by time, and only packages of that what you talk when you have a phone call are sent into the network. And the frequency on what you talk when you are connected to a mast is divided. It's divided every 4.615 milliseconds. That number of the milliseconds you don't need to know, but you can know that everything what you talk is divided and it's not real time. The main reason for having this system is that many people on the same place should be able having a phone call. So now maybe some of you are now asking, okay, that's nice to know, Harry, but only 8 people can have a phone call at the same time. We have, I don't know, millions, for example, around about 9 million inhabitants in Austria. We have places in Austria or in every country where many people are, and definitely more than 8 people want to have a phone call at the same time. How does that work? That is what I will show you now on the next thing that I will paint for you. If I now paint a situation like in Austria, in the middle of a city center, we have maybe some houses. This is a higher house now with a lot of floors. There's a smaller house. So how does it look like today? First of all, in many cities, you will see on the roofs some kind of called base stations. The technical word is base transceiver station. That's the mast, yeah? And that's on different rooftops, for example. Secondly, especially in office buildings, you have different in-house senders and receivers in each floor. And what they do is they all send signals on a certain frequency. So for example, that mast on the rooftop covers the house to the opposite. The mast on that house covers the street. The mast on that floor covers this one, this one, this one, this one. And now every area, every cell has a certain frequency where it sends. So for example, this is the frequency 900. This is the frequency 890. This is the frequency 898. This is the frequency 902. This is the frequency 908. This is the frequency 800 and I don't know what, 91. So the frequencies are reused, and in each cell, no matter how big it is or how small it is, we have 8 time slots. Every 4.615 milliseconds we can talk. What does it mean? The reuse of frequencies at the same place gives us the possibility, that you have a multiple usage of speech and phone calls over the air at the same time. So for example, 1, 2, 3, 4, let's say 5 times 8 people. And then we are already at 40 people that can have a phone call. And that's how in reality network planning works. And that's why in reality we have the situation of many, many base stations and in-house base transceiver stations that give us a network coverage. Because you can imagine this is not a real picture. In a city we have, for example, also an underground station. In the underground we have certain frequencies and not the same like on the street. And the frequencies have always to be changed, that the neighborhood frequency is a different one, but the mobile operator can use the frequency again in another area. So for example, if you take my picture, the frequency 898 is, let's say, in Vienna on the Währinger Gürtel at the university used in the 5th floor, but it can be used again, I don't know where, let's say in the middle of the city center near the St. Stephen's Cathedral, because that's far enough away for using the same frequency again. That's why mobile operators.
But how are they able to communicate? Because I thought the issue was that countries weren't able to communicate with each other, or that they had different frequencies in Switzerland and Austria and USA and everywhere. But how are they communicating now, since every slot is having a different frequency?
That's a little bit, which goes a little bit, a question that brings us a little bit into deeper technology, which is on the slide here. I can answer that with my slide. Let me close the painting and let me come back to my PowerPoint slide, then you will find the answer there. Once I can have the screen, just a moment. So here we are. Here you see the screen again of my PowerPoint slide. And in reality, it's that way. For example, I told you on 900 megahertz or around about 900 megahertz, GSM1 decided to have the network frequency. And in reality, it's divided in every 200 kilohertz channels. So you have in the area of 900 megahertz, you have 124 channels, because every 200 kilohertz there is a channel, and this is implemented in every mobile phone over the world. Every mobile phone over the world, no matter if it's my iPhone XS or a Samsung Galaxy, blah, 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 they have a chip inside with 900 megahertz and 124 channels, means they start with 890 and they go up to 915 for the uplink, and for the downlink 935 to 960. That's when people talk back. And this is in a chip in the phone, and this is one sender and receiver for 900 megahertz for having GSM phone calls. And that's a standard all over the world. So your phone, my phone, and the phone of our colleagues from no matter where, Russia, Bolivia, or anywhere else, every phone, no matter if it's from LG, from Apple, from Samsung, have a chip for GSM 900, and they can listen on all these 124 slots and frequencies that are used in every country, everywhere. Does that answer your question?
Yes, thank you.
All right. So that's also the deepest technology issue that I want to tell you. Yeah. And I want to be now related to the practical topics, that there is one service behind what those guys invented that will always work. And that's the service of SMS. Let's get back to the slides. Here you can see a note. 1992, on the 3rd of September, the first SMS was sent. Why do I tell that to you? SMS was not really a topic for those guys, because they worked on having phone calls and being able to have phone calls with everybody everywhere around the world, as I told you. But as a, let's say, besides product or besides solution, the guys developed the service of SMS. And they said in each channel where we have those 8 different gondels, as I told it to you, we make one gondel to transport text. So in reality, on one frequency, 7 people can have phone calls and talk, and the 8th time slot is used for the transport of text and data, for the signalization. And that was the reason why in the beginning of SMS, you only had the possibility to text 160 digits, because not more digits were possible to enter a gondel, because of the time topic that I told you, because of that topic that it only comes every 4.615 milliseconds, and that there are only 576 microseconds left to put text into the gondel. That was the specification of SMS, and they did not charge anything for the SMS in the beginning, because it was a besides product. Today, SMS is charged, as we know. We can send more, and for sure we have other services like WhatsApp and so on, where we come to later on, and where you will learn a little bit in other sessions, not with me. But the basic was SMS, and still today, one thing that you can remember, even if you don't have a 4G or a 3G reception on your phone, GSM coverage is nearly everywhere, especially in big countries or in countries with high mountains. Not everywhere, because the coverage is also very expensive. There are not masts everywhere on every mountain, or I don't know where in every area. But GSM is the most provided frequency all over the world. And sending an SMS is nearly always possible because you just need a time slot, no matter if you have a bad reception. And that's the reason, and that is what you can remember: critical services, alarming services for the police, fire brigade, etc. Also services at events where many people are on the same place, where thousands of people want to send something. Mostly the data coverage goes into its knees and comes to its ends, but sending SMS will be still possible because the signalization channel is always there. So that's a side knowledge you can have about SMS. So now what happened in the evolution? We are now ready and finished with technology. If you don't have any other questions related to network technologies, I listen to you and read also your question and know the question was, will we have to know all these technology processes for the exam? My answer is no. That's just for you and for fun. That's just for having basic knowledge. Yeah. So if you go out today from that session and you say, all right, I know that was critical with having phone calls. Sorry. And when you go out and know that it's critical with having frequencies in each country, and when you go out of this session and know that SMS is maybe always possible, even if WhatsApp is not possible, then it's fine. That's something like general knowledge. So coming up in today's world, what's happening now, as I told you, we have generations of the global system of mobile communication. And we are now, I was now talking about the first generation, and I will now go back to you, with you to the whiteboard, clear that one and make another nice picture. Hope it's white again. And what I will do now is I will paint a phone like it looks mostly today. And I will give you the insight about what's in your phone, especially for having data traffic and phone calls. So first of all, as I told you, there is one sender and receiver around about 900 megahertz, which is G1 or 1G, GSM, first generation, for having phone calls and sending SMS, which it is still today, worldwide. Then, again, due to a lack of possibilities and coverage, very soon the manufacturers came up with the next frequency with 1800 megahertz and a higher ratio of data transmission, because that is one thing that I want also to give you as a knowledge. In the GSM network, when you sent SMS or when you did some kind of data connections, you did not have more than 9.6 kilobits per second as a speed. And that's quite boring, as you can imagine. But 9.6 kilobit per second was that what was possible to transport in a gondola. So Physicians again came together. The next possibilities and physical aspects were developed. Thanks God, the second generation was born of the global system of mobile communication, so 2G. The data transmission was called GPRS. That is something what maybe one or other of you has on their phone sometimes when they have a bad data reception. Higher frequency was needed. The packaging was different. We could have speeds around about 56 kilobits per second. That was related to the good old modems we had on the fixed line network. Then maybe where every one of you is aware, the third generation. Do you know, or does anybody of you know the abbreviation for 3G, how it is called? I know that everybody of you knows because you're using it every day. No, not GPRS. No, not LTE, but what could it be? Any one of you knows, I'm sure. No, not WAP. WAP was the protocol for developing websites in the 1G network. And the question was, what's the name for 3G? It starts with an U. It was called UMTS. Yes, Miriam. Yeah. And it was called Universal Mobile Telecommunication System. GPS, by the way, was called General Packet Radio System. This is all technology bullshit bingo. You don't need to know it, but for example, you will read it sometimes or you heard it sometimes, and now you heard it from me. So Universal Mobile Telecommunication System, just another name, but a real revolution because the transformation of data over the air was changed with different protocols and speed increased rapidly. When they launched around about the year 2000, the UMTS network, we were already able to send around about 2 megabits per second. And that's great. That's what we still also use today. That's what we also have sometimes at home in our DSL or ADSL fixed line internet providers. So great speed, UMTS. UMTS coverage quite okay, especially in Middle Europe. In many countries, still not really okay. So it was a data revolution, another network, and it was and is sending round about 2000 megahertz. Okay, not enough. They came up with the next evolution, which is also implemented in our phones as a sender and receiver. Somebody already said that, the fourth generation. What's the name and the abbreviation of the fourth generation? Yes, LTE. What does it mean, LTE? Does anybody know? It means long-term evolution. Another bullshit bingo word. But another name for another technology generating more speed, 4 megabits per second. The best that we can get today. And on what are the operators working worldwide and what's especially in the media many times today? 5G. Does 5G have an abbreviation already? Yes, but it's not standardized. So I always say no because there is no global one right now. Yeah. So everybody is talking about 5G. We will see if their name will come up or not. But that is now, if you have a look at what I painted here, these things here, These are all senders and receivers. These are all chips and antennas, microchips, not Kelly's chips, that are implemented in your phone. So on every frequency, your phone needs to have a sender and receiver to be able to use it. And they pick up, every phone picks up what it gets. So if there is a 4G reception possible, it takes the 4G network. If there is no 4G reception, it looks after a 3G. It always looks after 1G, GSM. Because for having phone calls, most of the network operators send you on the 1G frequencies to save data and traffic on the other frequencies, where mostly today data traffic occurs and IP packages having a race during the lines and over the air. So that's the short explanation about frequencies and mobile networks. And let me, at the end of that session about the basics of mobile networks, give you some more information about the whole system. Because here is a phone. Then I already painted for you a few minutes before those houses with the base transceiver stations. So here you will have a radio access. Depending, the distance can be anywhere between a few meters and round about 30 kilometers. That depends on the configuration of the sender. On the count side, there is a sender and there's maybe a wide area that is covered, around about 30 kilometers. In the city, as I told you, there are floors in office buildings that have one sender. So a closer cell, a smaller cell. On the count side, maybe it's a wider cell. At the end of the day, the last thing that I want to give you as a basic knowledge is here at the mast, it's not the end station. Because what has to happen? The signal that you send, if it's WhatsApp, Facebook messages, or using an app, or the voice, the speech, that what you talk, if you talk to somebody, has to be sent anywhere, either in the internet to a server, or if you're having a phone call with another partner, to that partner. And that's why behind every mast, on every house, every mobile operator has to have internet. They have to have a transport line, and that's all done via internet protocol. And they have small lines from the base station, then they have nodes, and then they have bigger lines to the center where they have their servers, their billing centers and everything. So there's a great network behind, which I don't talk about now in that session because that's not necessary and not part of the course. But there were some basics, and I think you could give some kind of, let's say, or you have now the opportunity to think about some basics, especially when it comes up for creating services, creating mobile services. Think about that issue that I told you with the SMS. It's not always possible to have data reception in critical aspects. Maybe you stick to SMS services. That's the reason why it is also today in the real world implemented in many cases and in many business-related services. There was some, let's say, abbreviation about how the networks are handled, how many senders and receivers are in your phone, and what gives us the possibility to have phone calls or data traffic today. Are there any questions related to mobile networks?
Yeah, I have a question regarding 5G. I think there is a big outcry in social media about 5G. And I wanted to ask if you could explain why there was never a problem with 3G or 4G and why there is now such a protest going on with 5G.
Yeah. So in reality, there was always a problem with everything which is over the air. Yeah. The thing is the only thing to give the answer in a short sentence. 5G needs much more senders and receivers than all the other technologies from the past. Because 5G should give us the possibility to connect thousands of items, phones or refrigerators or cars or whatever, in a small area. That means they need a lot of bandwidth and they need a lot of masts. And now we have the situation already in every country. We have a lot of masts. We have a lot of base transceiver stations. We have a lot of signals running through the air. Coming up with 5G, there is also the discussion coming up about, do we need that? Do the signals affect us, our daily lives, our health, whatever? Yeah. And that's the reason, because 5G needs much more senders and receivers than 4G, 3G, 2G, 1G. And that's the reason why that discussion is in the media, and a little bit also there is a split between the parties who are working on 5G or who are working in the health sector.
Okay, thank you.
Welcome. Any other questions? Perfect. Then I would say for now, I come back to my slides, show you something on my slides. So, do you see my PowerPoint presentation again? Just give me a yes in the chat or say yes.
Yes.
Yes, we see it.
Thank you. All right. So next part would be about smartphones. For that, I would now have a break. And let's say we will have a break round about, let's say 30 minutes. Yeah. So let's meet 10 minutes past 8. And the thing is, first of all, for sure you make a break. But secondly, my wish is that you watch those 2 videos that are here on the slide. I already uploaded the slides into Moodle. So you will find the whole deck into Moodle. And you can go to slide number 13 and click those links and watch them. The rest is for sure a break. And we meet each other and are back again 10 minutes past 8. Is that okay for you?
Yes.
Perfect. So have a nice break and fun with watching those short videos about smartphones. See you 10 minutes past 8. Thank you.